Here, so this is exciting news. After many sleepless nights and lots of work, I now have PC control of an industrial robot arm, which is no easy feat. So I'm going to go ahead, see there's the robot sitting there. I'm going to go ahead and put my mouse over this spot here. And you can see it moving in a 10 millimeter increment or 1 centimeter between 50 and 60 off of the 0 on the x-axis. So that seems kind of simple, right? Well, let me walk you through all the craziness that goes into making that simple thing happen. So first thing I need to do whenever I want to talk to the robot is I need to use a start call command, which is 0x05 in hex. It basically says, picks up the phone and says, robot, are you ready? It will then respond with 0x06. So I've been using a serial monitor here to figure this all out, but 0x06 is basically the acknowledge command. It's like, yep, I'm here, send me your data. And then I send this string of data. This was the fun part to figure out. So thank you, Jim, for helping me work through the insane set of manuals. They handle the logistics, and they're not even completely accurate, which we discovered. So first digit here, the 0x5A is proprietary. That basically is like, you call a person on the phone going, is this Jerry? And he'll go, yeah. That way he knows I'm talking to the right command. So 0x5A basically tells the robot that I want to send a variable to its registry. So it works kind of like a Windows registry where it's just a global data set of where numbers are stored. That 0x04, the next number here, is how many bytes are going to be following this number. So I have 4 that are following it. So I'm sending it 0x05. That is the position register. So basically, if I go into data on the screen here, number 5 is in the registry as number 5. It's my speed. And I'm currently using it for position. It's a little confusing. You can see a number 60 there. So in position 5, I want to write 0, 0, 2 leading zeros, and then 03C, which in hex is 50, and up here is 032 is hex for 60, are my two numbers I'm sending. This last number here is a checksum using XOR to figure out the sum of these bits to give you a error correction or error checking. The robot will ignore it if this data is not valid, because you don't want an industrial robot running off rogue on you from an invalid data point. Thanks you again, Jim, for helping me figure out and writing a script to calculate that checksum for me. So then sends that. When it's done sending that, it has to send the 0x84 line, which basically says, I'm hanging up, and hangs up the phone, and then it responds back with, gotcha, we're done communicating, and then the whole string starts over again. So I just have a loop that runs through that sends it basically to 50 and 60 and back and forth again, handling that communication protocol, which makes the robot move. So how does the robot actually move? Well, if we go to edit here for this is the extent of the program. So I basically have label 1 here at the beginning, and then a loop at the back, and then it just repeats back. How this works. So basically, PR stands for position register. That is a global variable of X, Y, and Z in wrist angle where the robot's sitting. It's set up as an array. So comma 1 tells me that first bit of the array, which is the X position for translating Cartesian coordinates, I want to use this variable, number 5, which is the one I wrote via the serial port. So I sent the value 50. I want you to take 50 and put it in the X position of the array for the register of the robot. Once you've done that, I want you to go to position register 5 at this speed. So basically, if nothing changes on that variable, that R5, it'll just keep staying in the same position over and over again in an infinite loop, which is what it's doing right now, under running. But if I change that value via the serial port, it'll update the position the robot will move. Why is this such a mess? Well, Fanuc robots, they really like your money. If I want to talk to it via serial port from a computer, that's a PC interface, and that's $1,000. If I want to talk to it via TCP/IP socket commands via internet, well, that's $1,200. That's an extra feature. Oh, you want to talk to it via serial port? Well, that's a Corel interface. That's another $1,000. You can see the chain of command here. Everything's an expensive feature. So what I'm doing is I'm hijacking a protocol that they put in for free because it's called the sensor interface. They sell sensors that go on the end of the gripper for like force sensing. It's a serial output that goes into the controller. So I found a manual that relates to the serial protocol for sensor interfacing, and I'm hijacking that to send offset commands to the robot to then offset where it thinks it is in space, so I can basically control it from a computer and tell it where to go without actually having all those fancy protocols and commands in place. So what does this mean? It means I can do some really cool stuff. So next thing I want to do is I want to build like a toddler robot. I want to put a cookie in the gripper and put a laser rangefinder in front of it. And wherever I put my hand to try to grab the cookie from the robot, it will move quickly away from that position so I can never grab it. It's going to be really exciting. Make sure you guys stay tuned. Thanks for following through this long video explaining all the tech behind this. I just want you guys to understand that this was no simple feat to figure out all the protocol. I even had to dismantle the serial port to figure out if the pins were wired right, because it uses, of course, a $50 proprietary serial port interface. Awesome stuff. But make sure you guys let me know what you think, and thanks for watching.